research methodology. I welcome all the researchers and students for this workshop, in which you will be having a hands-on uh, experiential workshop on using SPSS software. Ladies and gentlemen, I would like to know, do you have SPSS software with you?
Yes, sir.
Do you all have? If you do not have, then kindly install this software called PSPP, which has got this similar interface and look and feel like SPSS. And let me post the link to this chat. Chat is disabled, is it for me? Uh,
Yes, sir. No one can enable chat, so there is no chat option.
no option. Then how can I post the links?
Sir, can you just share it in the WhatsApp group? I guess you are added to the WhatsApp group.
I have already shared it in the WhatsApp group. Okay.
Okay.
One way is, okay, I'll paste it on the uh, notepad. I hope you can see this. So
Yes, sir.
those who do not have SPSS, you can kindly download it. It's just a 20 MB file, and you can install it within 5 minutes. Okay. And ICSSR people are very well aware of this SPSS software. I used to work with SPSS 25 years back, and we used to interact with ICSSR and all the sister concerns to promote this software earlier. Currently, I'm an entrepreneur based in Bangalore, and I conduct a lot of trainings in analytics, including SPSS. So if you feel any training is required in any of your institutions or for any students or any, you can always touch base me. But a lot of people are there today in the SPSS community. So today we'll be doing some exercises on parametric and non-parametric techniques. I have shared the learning material and the data sets with Dr. Sridhar. I hope everybody would have received it. Has it been sent to everyone?
No, sir. It will be sent in the end of the sessions.
Can you please share it with them right now, because
Immediately, sir.
They need the data sets. Kindly share it with them.
Okay, sir.
So this is the link to download the PSPP if you do not have SPSS. The reason is, I would have suggested you to download SPSS, but there is a problem with the IBM website, and it keeps on getting into a loop after loop, and you will not be able to download.
Sir, can you just show the link once again?
Once again, yeah.
Thank you, sir.
Right. Can I close this link? I'll minimize
yes, sir.
it.
Thank you.
Yeah, if you need it. Okay. So, are there anybody who doesn't have SPSS here? If you do not have SPSS, then I will use PSPP. Otherwise, I have got SPSS, that I can show it from SPSS. But both of them, they have the same look and feel. PSPP doesn't have the glitter of SPSS, but the same code, the same scripts it generates. And I hope you're able to see the screen properly. Okay. If you are having SPSS also, it will be having the similar interface. Okay, let us, in the morning, I hope that you had a session on research methodology in which you focused about hypothesis testing. Okay. So in hypothesis testing, you might have, Dr. Kannadasan might have taken the class. He also happens to be one of my very valued customer. I am Raipur. And so he might have touch based you on subjects such as parametric testing and non-parametric testing. Parametric testing is, you have parameters which are measurable. like mean, standard deviation, things like that. Non-parametrics are something which are not measurable with regular measurement instruments. Uh, Example, let's say you have red, blue, green. Can I ask you what is the mean of red, blue, green? What is the standard deviation of red, blue, green? It is not possible, isn't it? If I can ask you what is the mean of your salaries, mean of your age, mean of your expenditures, that is possible. Uh, okay, I'll also keep this Google whenever we need to do some research. Okay, so now morning they might have touched base you on these things. So you develop some hypothesis using a null hypothesis. Null hypothesis says there is no difference between our samples and our population, or no difference between Indians and others, right? So that is null hypothesis. Null hypothesis says everything is same. We had this Fevicol advertisement. Some people might have seen that where they do this Yakshagana. So he says every glue is same, and he goes and sits on that, the character. He goes and sits on a seat and it falls. So they wanted to show that every glue is not same, every gum is not same, every adhesive is not same. So in real life, yes, we come across situations like this, and null hypothesis says everything is same. There is no difference between things. The alternate hypothesis, when it is investigated, when we are based on the data which we have received, it may say the null hypothesis is right or null hypothesis is wrong, right? So we conduct these statistical tests on this hypothesis. Parametric tests we use when we want to measure things like is our salary same as the Indian national salary? What is the mean? What is the average uh, Indian income? What is the average Indian income? It says the salary is 16,000. The Google says this is the Google figure, which it might have got it from the income tax department. In India, the average salary of the people is around 16,000 rupees INR. If your salary is above that, then it disproves. If your salary is equal to 16,000, it will prove null hypothesis. Or we can have alternate hypothesis saying that the average salary of the people attending this workshop is more than the average salary of Indians. If that is proved, okay, then that alternate hypothesis is proved, right? So this is about average, this is about something like a salary. So now for this we do conduct a parametric test. So there are different parametric tests which we do, and non-parametric tests, like uh, it becomes difficult. For example, as I said, red, blue, and green. How do we compare red and blue and green? Okay, so we use some rank. We convert this red, blue, green. We code them. Maybe say red is 1, blue is 2, green is 3. Then we try to find out how many reds are there, which we call it as frequency of reds, frequency of blue, frequency of greens, and then we try to see whether which are the same or the different. Okay, and one more thing is in this parametric test there are certain assumptions. Non-parametric test also we have different assumptions. Parametric tests, we usually consider it from the population. The population figures are known to us, like the national salary, the average salary of people, national salary, which is the population salary of India, 16,000 rupees. Once it is known, then you collect some sample of people attending this workshop and ask their salaries, and then you compare it with the national's salary. So that is a parametric test. And the we can do for a sample in the workshop, outside the workshop, or wherever it is measured against something which is measurable, that is the salary. Now, non-parametric test we want to measure. Example, uh, the national breakfast of India. Okay, so I say idli is the national breakfast of India. If I say is it correct? Is it wrong? So we will have to take some samples from different regions, and we'll have to see, you know, North India, is it idli? East India, is it idli? West India, is it idli? Okay, how many numbers? And then we have to do more processing in that. So non-parametric test can help us in those type of situations. Okay, so parametric tests usually comes from the population, and non-parametric tests, we don't make assumption about the population. So without population's assumption also, we can conduct some non-parametric tests. We can compare the breakfast of South Indians with the breakfast of East Indians or West Indians or North Indians. We take down some, we rank them, or we find out the frequencies, and we conduct certain tests. So now we evaluate hypothesis using parametric and non-parametric. So for parametric tests, the sample size is also important. Based on this, we make inference whether the population and the sample are similar or dissimilar. So non-parametric tests usually we have in situations where our sample size is less. Our sample size is very less, and the variables which we have may be ranked. They are not actual scale data. They may be ranked data, or what we call as a nominal or a ordinal data. I hope everybody is aware of this nominal or ordinal data. You code things like, red, blue, green, idli, um, pav bhaji, then paratas. We code them. So, so in parametric tests, we evaluate hypothesis for a particular parameter, which is usually a population mean. We have a quantitative data. It requires assumptions about the characteristics of the population. We said that the average salary of Indians. Okay, so we assume it to be normal shape. It need not be normal also. It need not be normal, but we make some assumptions on the population data. We assume that there is equal variance everywhere, and we take a sample from in Karnataka or Andhra Pradesh or somewhere. We measure the average salary of the people there, then we compare it with the average salary of Indians. Okay, so that's how we do the parametric test. It is more powerful than a non-parametric test when assumptions are met, and it's very good in doing predictive analytics. Okay, for predictive analytics, these parametric tests are very helpful. It gives an idea how our predictive models will be, how accurate it would be, whether it will work even when in all situations. So it can give us an idea. When it comes to non-parametric tests, we don't have to consider about the population. Example, Let's say we are doing some analysis on AIDS patients in your city. How many AIDS patients may be there in your city or in every village? Very less, very few. But you're taking so much of readings from each one of them. It could be what is their age, what is their economic background, what is their employment status, uh, what is their food habits, do they have any other morbidity, like that we can keep on taking. So you may have some one or two records of data, but you may be having some 25 variables for each one of them. So for such data, we cannot conduct parametric tests. We do non-parametric tests. Hope people are clear about this thing. Okay, so non-parametric tests we usually conduct for complex data where the variables can be more than the number of records. Statistics says if you take one variable, if you have one variable, at least there should be 10 records. If you have two variables, you should have 20 records. If you have three variables, you should have 30 records. If you have 25 variables, you must have 250 records at least, independent. Each one is independent. But that doesn't happen usually. So if you are conducting some analysis on AIDS patient or a tuberculosis patient or something like that, so it will be just very few, but you will be collecting so much of other variables. So here we cannot make uh, inferencing that if these two people are cured of tuberculosis or AIDS, the entire India will be cured of tuberculosis or AIDS. That type of inference we cannot make out of this non-parametric test. But this is generally easy to compute. Okay, it is easy to compute. Now, just I'm showing this, many of these diagrams I have taken from the internet only, but it is very simple for you to understand. So that's why I'm giving this. So you have a research question. You wanted to see whether things are same or things are not same. So if we use parametric tests, we have one sample parametric test and two sample parametric tests. In one sample, we have a t test or a z test, depending upon the type of distribution. At least you should have some 30 records to do this parametric test so that it can be considered reliable. You should have some 30 records if you want to do a parametric test. So if it is less than 30, we conduct a parametric test and simultaneously we conduct a non-parametric test also on the same data if it is less than 30. Many times when the distribution is skewed, if it is not normal, when we are conducting a parametric test, the distribution is not normal, then also we conduct, for our safety, we conduct a non-parametric test. So in parametric test, if it is two samples, we do either independent sample t-tests, and if it is we are having data for the same samples in two different times, example before treatment and after treatment, same number of patients, then we conduct a paired sample t-test. If it is more than two samples, then we conduct an ANOVA. In case of non-parametric test, the equivalents are there for this one sample, two sample, and three sample test. So we have a Mann-Whitney test is there, which is equivalent of one sample t-test, two sample t-test. Then we have a chi-square, which is a special type of test in which both your variables can be categorical variables. At least in this parametric test, when we conduct this two sample test, the two groups, we consider them as categories and we consider their values. It could be salaries, it could be age, it could be their whether they are cured or not cured, things like that. So that is how we do it in two sample tests. So in non-parametric test, if you have two samples and both of them, they can be categories. Both the variables can be categories. Example, gender and employed. Gender, you say male and female, and employed or not employed. So you have two categories, and you can compare both of them and say whether male are more employed or female are more employed, or male are more unemployed and female are more employed. So we conduct a chi-square test. So we will I just wanted to touch base with these things, and then we will go ahead with the test. Okay. So I have given this material to the Dr. Sridhar and his team, and they will be sharing all this with you. I have given just comparisons. Let us straight away go with some tests. Okay. Now, have you all received the data sets? Can we start with the exercises? Have you got the data sets?
Also, the Excel sheet which you have sent out.
Excel sheet I had sent in the morning. Also, I have sent a zip file to your email. Yeah. Please
Yes,
share
the food company, we have got certain files.
that. In that, I have given specific data files for different tests today. Can you
I have shared everything, sir, except the files which have come in email. I'll just forward it in 2 minutes.
immediately please share that?
Yes, sir. Just give me a minute.
Okay, so now today we'll start with a test. So let us, in the first session, let us start with parametric tests, and then we'll do the non-parametric test. Maybe simultaneously we can do, or we can do it first. We can complete the parametric test, and then we can go with the non-parametric test. And I have given additional data sets for you. You can learn from that. And I suppose many of you are already veterans. You may be already familiar with this parametric and non-parametric tests. Now, this is a screen of PSPP, which is similar to the software SPSS. Okay. So when you open the software, you will see a grid like this in which you can enter data just like Excel. On the bottom, you can see there are two tabs called data view and variable view. In SPSS also, it is same. Data view is there, variable view is there. In the data view, you will enter the data, raw data. In the variable view, you can write the metadata. This is what is a metadata? It is the, you say what that variable is, what type of variable it is, what does it contain, how many places of decimals, whether it is the input data or is it output data. These things you can say it out in the variable view. It is a framework. It's the framework you lay it out for the data. Based on this framework, you can enter the data in the data view. Okay. So now let us show the menu. So on the top, you are having file. Under file, you can create a new exercise, or you can, please tell me, sir. You want to say something? Okay. So now you can open the data sets. You can import data from other types of data sources like SAS or some other database sources. You can save the file as it is, or you can save as Excel, or you can save it as SAS after doing all that analysis. This data set, this is only about the data set. You can rename the data set. And it also shows some of the data which you might have recently opened. So it becomes easy for you to analyze this. Then under edit, we can insert columns called variables, or you can insert records which are called case in SPSS and PSPP like alike. You can go to a specific variable or go to a specific record. You can cut, copy, paste. You can clear the variables, clear the records. You can find a particular value. You can find out the options about the menu, do something like that. So under data, okay, then you have view. Under view, you can see which type of uh, toolbars you can display. Under data, we can sort the data, we can transpose the data, we can make aggregation of the variables, we can split the file, and we can select some cases. So usually you researchers, you collect the data, and you might have collected data over different periods or different places. So you can select the cases for different places with the different conditions, whether you want to select the entire case or you want to based on certain criteria. Those things you can do it in this under data. Transform is a menu in which you can compute some new record. Example, let's say you are having sales and cost, and you want to create a column called profit and profit percentage. So for that, you can go to this compute and create a new variable. You can go and just click on it and say create a new variable, give the name, select the variables, and you can make it through some formula. It's a wonderful experience if you go through this transform. You can rank the cases, lot of things. So these are all done for data pre-processing or data cleaning. The statistical tests are done in this menu called analyze, which lists a lot of descriptive statistics, then our parametric tests and unparametric tests. In addition to that, we have regression, then unsupervised learning, clustering and factor analysis, principal component analysis, then classification techniques like logistic regression and other techniques are also there. So the entire analysis can be done in this analysis tab. Graph tab will help you to plot different types of graphs. This PSPP in SPSS there is a module. SPSS is modular. In SPSS there was used to be a package called SPSS base. So this PSPP is just like SPSS base. One-to-one comparisons we can make. It has similar, but when it comes to graphs and all that, it has got limited features because it was developed long back, and afterwards not much thing has happened. I think license credits. Let me see. It was developed. Now the latest one which I have is from 2007. So since 2007, not much development has happened in this PSPP. Whereas in SPSS, a lot of developments have happened. They have made a unified interface for statistics, modeler, and they have also web enabled it. So you can access it on cloud. That's about the software. Now, have you all received the data sets? Have you all received the data sets? I'm not able to get the response from the people because I don't have the chat window.
Yes,
They
sir.
all received.
Which, yes, sir. You can able to chat in a WhatsApp group, sir. I added in the WhatsApp, sir. So they can also interact through the WhatsApp.
Why that one? Two different platforms.
No, sir. Doesn't MS Teams doesn't have
No,
access the
okay.
chat.
Okay. Let me. Let me ask them. Okay.
Okay. They already forwarded two sets, sir. One is help.
Okay. Should I forward them on WhatsApp also?
Yes, sir. Yes, sir. You can, sir. You can, sir.
Let me. Then I have to go to web WhatsApp and I have to send it to them. No, this ICSS. Okay. Just a minute. You have already sent them. This.
Yes, sir. I have added so two data sets have been sent them, sir.
Okay.
Cancer,
Okay. Okay.
yeah,
Yeah.
cancer and food company.
Yeah. Here, let me send all the files. So this is the St. Joseph's workshop data files. Okay. So enjoy everyone. This has been sent to you. Download it to your desktop or some location. So here I'll be doing some exercises on SPSS. I hope everybody is young at heart and very familiar with the software. But still, sometimes some of the people are not familiar with the software or not comfortable with the software. They would like to do, because the researchers, they would like to do hands-on, right from pen and pencil. In fact, when I started learning 25, 30 years back, there were no software. So we learned statistical quality control, chi-square test, everything writing down. And that's how we were able to understand the concepts. So I've also given some documents in which you can learn these things hands-on. And also, if you want to do some of these tests in Excel, Microsoft Excel, you can do it step by step. That also information I have shared with you. Yeah, in fact, I represent another software called Statistica from StatSoft. It is also a wonderful software, very simple to use software, used by a lot of researchers in almost all sectors. And it is also very economical compared to SPSS in terms of pricing, and they have special pricing for researchers and academic institutions. And we also conduct a lot of workshops for FDP and Atal FDP, all such programs we have been doing it. Now that's about Statistica. Now let us come to this SPSS thing. Now we will start with an exercise on doing one sample t-test. One sample t-test is, we have something like our national income, we knew, and we collect the data from our sample group about the income, and we try to see whether they are similar or they dissimilar. So that is how we do a one sample t-test. So here I have sent you different data sets. So in that I have given one file called one sample t-test. P stands for parametric, NP stands for non-parametric. P one sample t-test I have sent you. This is the data file. But let me see if I can increase the wait a minute. Screen resolution. Let me see if I can improve the screen resolution. You will be able to see it better. If I make it less than that, can't I make less than that? Oh, it is also freezed. I can't do it for 600, 800 by 600. It is freezed. The recent laptops, they don't enable for lower resolutions. Let me try again. I go to graphics options. No, so no luck with this. Okay, so let us start with this thing. Okay, so here I am having some data about some height of plants. It is just like our salaries. A group of from the sample, we collected the salaries of people, and like that we have collected here also. We have collected the height of plants done by some researcher. Now this researcher, he has done some. He has grown these plants, and he has. It's some special plant he has grown, and he comes to know that this when it is grown in some other places, okay, the average height of those plants will be around 15 inches. 15 inches. So now he has done, after some 4 weeks or so, he has taken those plants, he has measured them. These are all measured. Now you see, I am having only 12 measurements. Only 12 measurements, but these are all measured. These are all measured. So we can do parametric. We can also do non-parametric. We can do both of them. Okay. So to start with, parametric. So there is only one variable, which is the height. So this height, you see, I am showing you the variable view, which you can see in your SPSS also. The height is the name of the variable. It is of the type number. It is a scale. It is a scale. The measure is scale. It is not. Sorry. Okay. Sometimes the software will go to something. So the measurement of that thing is a scale, and its width decimal. If you want, you can have two places of decimal if it is given in decimals. Otherwise, it is 0 places of decimals also you can have. So let us come back to the data. Now the only one call. Now we are trying to measure the average height of these samples and compare it with the population height, which has been given to us as a standard. Now let us say that population standard is 15. So we wanted to see whether this is very close to 15. Whatever this group which I have grown, there are some which are less, which are some which are more than 15 also. But as a group, can I say it is 15? So to do that, you go to analysis tab. Under analysis, you have compare means. Under compare means, you have what is called as a one sample t-test. Or before that, we can also do some graph. We want to see the pattern of the data. So let us do a histogram, because it's a continuous data. You can see how does the data look like and try to see whether we can fit a normal curve, because parametric tests will like normal curve, normal data. So now you see this looks somewhat normal, good. So this will give sometimes a misleading relation. The data is very normal, so parametric tests are the right kind of tests we can do. Okay, it satisfies those conditions for parametric test, that the data should be drawn from the population, it should be normal, and each of the records should be independent. So it satisfies all that. So it looks like almost normal, little bit out of normals are there, still it looks like a normal data. So this is the output screen. Are you all able to see the output screen?
Yes, sir.
Okay, wonderful. So if you are able to see the output screen, so you can see there is a code also which is generated when I did the exercise. So similar type of code is also generated in SPSS, which we call as a script. You can save those scripts and you can reuse them. or you can embed it into some other applications and you can build a solution out of it, right? So this is about it. And if you want, you can copy this to, you can right click and copy to your PPT or MS Word or Excel. Okay, these graphs and reports, that is possible. You can also export, going to file, export, and you can save it in some location. So the histogram shows my data which I have collected for these plants. I have planted them on the same time. I have planted 12 different plants planted at the same time, and they have given the growth. But in that, you see, I've given the same type of treatment, and in this, you see, some of them are big, some of them are small, but on an average, most of them, they are coming towards the denser middle region. So it is looking like a normal curve. So let us go back to the data view. So once we have seen that, we have visualized the data, then we say, okay, we should do, I'm having only one column of data, we should do one sample t-test, because this is from one group I have planted and I have got it. Okay, so I go here, and you can go, a small window will open, and on the left hand side you will see the names of the data which are there, which you are taking for analysis. Select this height and push it towards the right side as a test variable. Below that, it is asking what is the test value. So here you can say the population, whatever the population parameters they would have given you. So there they might have said it is 15, 16, 14. So we can test for each one of them. They might have also said the national growth is only 10. So if national growth is 10 and you have got more than 10 and you have got 14s and 15s, your sample is very good, maybe, isn't it? So here, let us say I will first test it for 15. I will take 15 and I will test it. After testing it, I will go to the output window. In the output window, I have got some results. What is that result? It says, the result says there were 12 samples. The average height of these plants is 14.33 with a standard deviation of 1.37. So it could be 14 plus 14.33 plus 1.37 or 14.33 minus 1.37. Okay, like that. Then there is a standard error of the mean, in which you have the standard deviation of 1.37. You divide the standard deviation by the total number 12, square root of that. That will give you a standard error of the mean. So it has given that values. Now, in the one sample test, we have what is called as a t statistics, a student t statistics. The t, there is a formula called x minus mu divided by s divided by square root of n. Can I use the annotator here? Let me see. Is the annotator available? This Teams is so unfriendly. It's just a portal it is showing. Okay, let me see. If I can zoom it or something. Okay, so there is a formula that I could not. Let me just paste that formula. Sorry. Yeah, this is the formula. T is equal to x minus mu X is each of the sample, mu is the average, that is that 15 which I had got, and yes, sorry, is 14.33, that sample what I have got, and sorry, we are measuring the one statistic. So X is that 14.33, and mu is that 15 what I had mentioned, and S is the standard deviation which I had got. Square root of n is square root of 12 which I had got in this case. Okay, so 14.33 minus 15 and divided by this 1.37 divided by square root of 12. So it gives out some figure here. This t value and degrees of freedom is the total variables minus 1. You take these two values t and df in t student t table. Okay, so you get a graph. This is how we used to do earlier. Okay, so you have a t distribution thing. Okay, so here, so for that degrees of freedom 11 we had got. So for that 11, and we are taking 0.05, and 0.025. So it comes to one tail. One tail is 0.025. So here I am getting 11 is some 2.20 something. Okay. So this gives this value, based on which there is something what is called as a p-value, which is computed out of this statistics. Okay, let me close this thing. So here we get this significance two-tailed value. It is showing it as 0.12. 0.12 is greater than 0.05, which means to say there is no significant difference between the average of these samples when it is compared to the population average, which was 15. So here we are getting 14.33. Looking into the mean only, we can make it out. Yes, 14.33 is very close to 15. So there is no significant difference between the average height of the plants in this group, which we have collected here, and also our sample, our population. So did you all get this result? So if you go to analyze, compare means, one sample t-test, select this height and do it, you will get that result. And you have tested it for 15. Now if I test it for 10, let's say if they said that nationally, in the national, the average height of the plant was only 10 inches. So now whatever you have grown with your chemicals and your manure and all that, does it make a significant difference? Are you same like your population, or are you different? So when I do it, I get to know this is different, isn't it? Because the national, it was having only 10 as the height, whereas you are having 14.33, which is far higher than that national average of 10. So in the one sample test, it says your samples are different from the population because you might have done some additional treatment. Your way of growing plants is better. Your way of growing crops are better. Okay. So one sample t-test helps you to measure your scores against a population score and only one variable is sufficient for that. So here I had only 12. Now 12 have grown, wonderful. But is it only for this only 12? Suppose tomorrow I get another 12 and I grow it with same thing. Will they also grow with this similar things, or if it becomes 5 or if it becomes 25, we do not know, isn't it? So considering this as not a scale but as a like a rank, like instead of thinking this as 14 inches, this is 14 rank. This belongs to one group of all 14s belong to one group, 16 belongs to one group, 13 belongs to one group. So if this is a considering this like a ranked data, then I can also do a non-parametric. So to do that non-parametric, go to analysis. Under analysis, you go to non-parametric. Non-parametric, I have one sample KS. Okay. Can you do this? Go to analyze non-parametric statistics, one sample KS. So in this one sample KS, take this height and put it as a test variable. You can test this against a normal distribution, uniform distribution, exponential distribution, Poisson or Poisson distribution. So in SPSS also you can do like this. So when you do it, because the samples are less than 30 and we think that it is just a rank, it is not the actual measurement, it is the group. So when you do that, then this non-parametric test also is done in what is called as a Kolmogorov-Smirnov test. Kolmogorov-Smirnov test. So here it gives out so much of vomiting. It is very difficult to understand these tables. Okay. So much of things are there. So what it is saying 12 is the number of samples which you have taken. We are considering mean and standard deviation. Okay. And the extremities were there. That also it says, and it says considering between these, one is having one is there with 18, another with 17, another with 16, 14, and all that. The counts, the frequencies which you have got for each one of these, is there any significant difference? So here it goes and it says, considering the normal distribution, when you consider the normal distribution says, sir, this is not much difference between these groups. There is not much difference between the frequencies of these groups. They are similar. Now, if I consider this to be a uniform distribution, if I consider this to be a uniform distribution, all are supposed to be 10, 10, 10, 10, 10, or 15, 15, 15, or 14. This is not uniform. It's fluctuating. It is fluctuating. So uniform distribution says, yes, but that difference is not much. 53.1% of these plants, they are having similar 53% of these samples which we have taken are having similar height. So I don't think it is different. I don't think they are different. They are same. Then I go and talk to Poisson distribution. Poisson distribution says it is as per Poisson curve. Each one, it is also found on each and every frequency. It also says, no, I don't see much difference between each of these frequencies from each of these groups. Okay, so Poisson also says there is not much difference between these groups. But when I go to our friend exponential distribution, The exponential distribution says, if you think this data will fit a exponential distribution, no, they are different. They are not as per exponential distribution parameters. So we are totally different from these these plants which are there. They are totally different from a exponential distribution pattern. So this do not fit the exponential distribution pattern. That is what they're saying. They are totally different. Whereas these three, they are saying that yes, you can fit. Out of them, normal says you can fit 83.5% of all your samples which you have collected and grown. They follow a normal distribution. They follow a normal distribution, and I don't find it to be different. I don't find them to be different. So this is the result of one sample Kolmogorov-Smirnov non-parametric test. Okay, so this is only for one variable. Are you clear with this? Could you do non-parametric test for the same data? Did you get similar results? Did you get similar results? Why no response? Madam, can you find out from the participants? Are they able to do?
Sure, sir, sure.
Find out, are they able to do these exercises? If the chat would have been there, it would have been better. Would have found out.
Yes, sir.
They are able to do it. Okay, you enjoying the workshop? Okay, wonderful. So we did only one variable we had got. Okay, this is from one sample. This is from one group or one place. Okay, so done at one time, and we have collected different records for that one group or one group. Okay, now if there are two groups, if I do this in another place, two different places, and I get it, so for that I will use a two independent sample test. Okay, so go and open independent samples t-test data. Two independent sample t-test data. So in the two independent sample t-test, I have given a different database. I have given a different data. In fact, in this also you can do it. Maybe you add another 10 from a different group. You will have to create a new group name. So you see how to do it. Here there is a group name and there is some parameter which we are measuring it. Okay, this is the miles per gallon of an automobile, and people like this Tesla, they have come out with some new, or our Indian Oil, they came out with high octane petrol. You know, they came out with a high octane petrol. If you have high octane, you will get more miles per liter. More miles per liter. Have you tried it? These high octane petrol are expensive, but if you use it, your engines will be very good and you can get more mileage. Have you all tried it? Okay, so when they have come out, suddenly there was a competition. The competitor company also came out with a high octane petrol, and they didn't have much time to test it on vehicles. So they have spent some time to test vehicles on old petrol and new petrol. Okay, so there are two groups of vehicles, which is a old vehicle and a new vehicle. And on the old vehicle, they have given old petrol, and this new vehicle, they have given new petrol. And they have got the results for the number of kilometers it has run. or miles it has run. Now, is there a difference between in the mileage for these two petrols, old petrol and new petrol? Okay, so that is what they want to analyze. So here they have still again got less data, 11 records of old vehicles and some 13 records of new petrol, new vehicles 13. So the number also varies. One is there, 11, another one is 13. Okay, so let us first of all try to see the distribution of data. To see the distribution of the data, you can use box plot in your SPSS. Here, if you want to do, or you can go and uh, go to compare, go to descriptive statistics, analyze descriptive statistics, go to explore. Go to explore. In the explore, what is that we are trying to find out? We want to explore the mileage, and we want to see the mileage with respect to the group. The group is in factors. Group is in factors or a rank, saying that 0 is something old, 1 is new. Okay, so you have to put your miles per gallon, which is the scalar data, in the dependent list and the factor in the factor list. It is asking what do you want to display. Let us see only plots. Okay, let us see, select only plots, and you can just say okay. If you say okay, and you can go to your output window. In the output window, we can see the first group and second group. This is what we are getting, miles per gallon. The first group, this is the miles per gallon of the first group, and this is the miles per gallon of the second group. Distribution. So here it says, looking into this distribution, we can say, the yellow color part which you can see, that is the average, almost the majority of the vehicles. In the first group, the mileage is around some 19 to 23. 19 to 23 is the mileage when they are using first kind of petrol, and it is 21 to 24 is the mileage which we get from the second kind of petrol. Of course, there are some very high and very low values also are there. It depends upon the state of the vehicles. But as it is, you consider that the vehicles are of the same age and you give two different petrols. So looking into the graph itself, we can see the performance of second petrol is making a good effect. Okay, it is giving good mileage. It is giving good mileage. That mid black is the median value, and here it is broken into quartiles. Q1, Q2, Q3, Q4 quartiles. The entire data is split into 4 when you arrange them in increasing order of the performance. Okay, so this is what we have got looking into the pattern of the data. Now here we have to do the test. Statistically, are they different? Can we say that, okay, this is for 11 and 13 numbers? Can I infer it for the entire population? This is for only a small sample. Can I infer it for the entire population? To do that, we go and do a independent sample t-test. To do that, go to analyze. Under analyze, go to compare means. Under means, you can see independent samples t-test. analyze, compare means, independent sample, t-test. Sridhar sir, is this getting recorded? Is this presentation getting recorded for the
Yes, sir.
participants?
Yes,
Okay,
sir. It is
wonderful.
recorded.
Okay, wonderful. So then they can get a, even if some people are unable to attend this session, there will be a backup to learn. Okay. So here, what we are interested to measure is the mileage and the groups to be put in the grouping variable. Now here there are two groups. One is 0 and another one is 1. So you have to define this group. You have to define these groups. So go to this thing. You say the first group should be 0 and the second group should be 1. Define the groups like this and you say continue. I hope everybody is with me. Okay. Go to analyze, compare means, independent sample t-test. Under independent sample t-test, push the miles per gallon as the test variable. Consider a group as the grouping variable. Below that there is define groups. Click on that and say 0 as the first group and 1 as the second group. And then just say OK. If you say OK, first we had got it in diagrammatical figures. Now we get it in statistics also. So under statistics, what we get? The first group has got a mean of 21.18 mileage. Second group has got a mileage of 22.46 and standard deviation, standard error of mean, all that. Okay, so both those groups, these are the data. No? So it says what is the mean, what is the standard deviation. This is the descriptive statistics, group statistics. Now comes to the independent sample t-test after we have done this. Now we consider equality of variance when we are doing parametric test. When we are doing a parametric test, we assume the variances of both the population groups, both these population groups, the one which were given 0 petrol and the one which was given that one type of petrol, both of them, they will have equal variations, equal variance, similar variance. That is the assumption. If they are supposed to have similar variance, then we conduct what is called as the Levin's test for equality of variance. Levin considers it as if the variances are equal, then there is no significant difference between them. So Levin says, yes, both of them, they are similar. I don't see much difference because the variances between this and this, the variance, you see, this is the variance. The variance between this and this, they are almost same. I don't find much difference. So he doesn't find much difference, Levin. But the independent sample t-test, it is measuring with respect to the mean. It is measuring with respect to the mean. So the mean values were, one was having 21.18, another one was having 22.46. Okay. So when you consider both of them, then if you think that the variations are not same, if the variances are not same, then you get the p-value here, which is called significance two-tailed. It is saying 0.313. So I don't find much difference. I don't find much difference between these two groups which were given, old petrol and new petrol. So why it has happened? You have invested a lot of money in your new R&D to develop a new petrol, and it is giving good result on some sample. But why we are seeing that there is not significant difference between these two groups? Because the sample size is small. or there were some, you see, there are some vehicles in this second group, in spite of giving second type of petrol, it was having only 16 to 17 mileage only. Maybe it's a very bulky vehicle, we do not know. So if you increase the size of samples, and also if they are from similar type of vehicles, then we will be able to see whether there will be a significant difference between using the first type of petrol and second type of petrol for the mileage. In this case, though diagrammatically I could see there is a beautiful increase in performance for this second type of petrol, statistically, to extrapolate to the entire population, I don't see much difference. And so it says I don't see much difference between that. So if you had increased the number of samples and you collect more data, you may end up in seeing differences between using first type of petrol and second type of petrol. So this is how we do the independent sample t-test, and we give the results. Now, this sample, one was 11, another one was 13. Should we not have used non-parametric then? That's a question you will ask, no? So now let us try a non-parametric test instead of a parametric test. So this is over. Let me close this. If I can conduct a non-parametric test, so how will I conduct that? So go to non-parametric this thing. I have k independent samples. K independent samples non-parametric test, because these are independent samples, no, 0 and 1, they were independent samples. So I take this, and mpeg is the test variable, group is my grouping variable. I can define the groups 0 and 1. Okay. So then here I will do what is called as a Pruscal-Wallis H test. Pruscal-Wallis H test is a popular test which is used when you are using this thing. So if you say okay, and you get the result. Now here, non-parametric test also says similarly, because even though there were 11 and 13, and the data you said that they are like ranks instead of actual numbers, they were different groups. 11 is 11 rank, 12 is 12 rank, instead of 11 kilometers, 12 kilometers per gallon. So when it has been converted like that, you try to see if there is any significant difference between these two types of vehicles. Non-parametric test also gives similar type of result, and it says I don't see much difference between the vehicles which were given old petrol and the new petrol, because the performances which we got from these two types of vehicles, it's almost same. So non-parametric also says there is not much difference between these two groups. Are you able to do this?
Yes, sir.
Yes, sir.
So did you understand? Okay. So when the samples were less, we may, with less samples, we try to, if in today's class, if let's say I understand that there are more than 100 people attending this session. Out of 100 people who are attending this session from everywhere, if 10 people are having idli as the breakfast, and you say that all the Indians will have idli as the breakfast, then it will be a wrong prediction. It will be a wrong prediction. So that is why we can't use a parametric test for that. So we'll use a non-parametric test. In the non-parametric test, only this group which we have got 10 10 people have 10 people are eating idli or something. So in that we can see whether only if it is 10, then it is not a significant this thing, because other 90 people, they are not eating idli. They might have had a bread or something, dosa or some other breakfast, isn't it? So each of them were different groups instead of numbers. So a non-parametric will help us to find out, considering these as groups instead of just numbers. Here, this is also numbers. So this MPG also will become like a group, and group also will become like a group. Okay, so here we are having 2, 0 and 1. So for this 0, each one of these is a group. 20 is a group, 21 is a group, 25 is a group, 18 is a group. So they all become like a nominal. They all become like a nominal, and chi-square test is performed for that. So chi-square test will do it later also. So here, that is where it has done the chi-square test in the nominal for 2 different samples. And it says, I don't see much, because if you consider, very less data is there for each one of these. For example, 0. Number of 20s may be less, 23s may be less, 21 may be less. As it is, we are having only 11. Among 11 data values, there are some 3 or 4 groups may be there. Each of these will be it will become like a group. 24, 2 is there. Then 23, 1 is there. 20, 1 is there. 21, 1 is there. So differences between them is very minute. So you don't find within them or within these groups, there is not much difference in the performance. So non-parametric also says there is not much difference between these first group and second groups when it is administered to the vehicles. Okay. So now I think we are at 12:45. Are we having a break now, madam? Are we having
Yes,
a
sir.
break?
Yes, sir.
Okay. So we are having a break and we'll be back at 1:45. So now we have completed 2 tests. One is one sample t-test and independent sample t-test. After the break, we can do repeated measures and ANOVA, chi-square. These are very easy. So to make it easier for you, I have named the data files in those names only, which you can do it. So this is the type of data it requires. When the data is less than 30, then we do non-parametric. Not only 30, if the data is in ranks, then we do non-parametric. If the data is in scale and less than 30, then also we can do parametric test. Sometimes parametric test will work good for them. Sometimes that sample size which we have collected may not be sufficient. So parametric test will not give good results when the samples are very less. Okay. You have any query? Do you have any query?
No, no, sir.
No query? Have you asked everybody, have they been able to do these 2 exercises? Were they able to do it on SPSS or on PSPP? Because when a online session on software is conducted, some people will be falling back, some people will be ahead. Ask them, everybody was able to do it. If you all have done it, I'll be very thankful to you. So we'll be meeting at 1:45 after lunch. and we will be there up to 3:30, isn't it?
Yes, sir.
Yeah. So 3:30 we will do that. Thank you.
Thank you, sir. We'll meet after.
Thank you, sir.
Participants, the third link of the session will be sent in the group. Please join to the link. It's at 1:45. Thank you.